Lesson 67, Solving and Classifying Special Systems of Linear Equations. And inconsistent equations have no common solution. Okay, that's what you need to know about inconsistent equations. They have no common solution. And it says, therefore, they must be what? Well, if you're thinking about a graph, okay, I know that if I graph a line that looks like this and this, the solution is right here where they meet, right? So what has to be true about those lines if they don't meet, if they have no solution, no common solution? They have to be parallel. So what you need to know is that inconsistent equations are parallel, and we should remember from the other day that parallel equations have the same slope. Exact same. I'm going to include an exact. Exact same slope. So, it wants us to solve. We're looking for the solution. So if I have a common solution here, so I want to solve for x and for y. So since y is equal to this and y is equal to this, I can put this part in for y. So I have 5x plus 6 equals 5x. Well, I want to get x on the same side, so I'm going to subtract 5x from both sides. Cancels, cancels. So that means that 6 would have to be equal to 0. Is that true? Absolutely not. This is not true, which means there is no solution. You could have seen immediately that these were parallel lines because they have that exact same slope. So if you see that they have the same slope and you don't even need to do the work to prove it, all you have to do is tell me same slope and tell me what the slope is, no solution. Dependent systems have an infinite number of solutions. Therefore, the equations are, if they have an infinite number of solutions, let's graph a line here. So let's say we're talking about this line. Normally, we have a point where they meet, and we say that we have one solution. But if they have an infinite number of solutions, if we're talking about this line, that would mean this is a solution, this, all the way down, everywhere, which means that they must be, therefore the equations are the same. Okay, so that means that the line is just on top of itself. So it wants us to solve. To get this x by itself, I'm going to add 4y to both sides, which is going to give me x, and then those will cancel, is equal to 4y plus 8, which I'm going to then take and plug in over here. So I have 1/4 times 4y plus 8 and minus y equals 2. Distribute my 1/4 to everything. 1/4 times 4y just gives me y, plus 1/4 times 8 gives me 2, minus y equals 2. Then I can combine like terms. When I put those together, those will cancel out, so I'll get 0y. I don't want to show that, so I'm just going to have 2 is equal to 2. Well, this is true. 2 is equal to 2. Alright? And you should remember from when we were trying to solve for just variables in equations, whenever we came out to this, we would say that this meant that there were infinite solutions. I hope that you remember that. Okay, so whenever if the variable cancels out and they are truly equal to each other, that means that we have infinite solutions. I could plug in anything for y, anything for x, and it's going to give me the same thing. Alright, so a consistent system has at least one common solution. At least one. That's the key there. That means one or more. So of the ones that we've talked about consistent and inconsistent. So the inconsistent has no solution. Consistent has at least one, which means one or more. And then we have an independent system has exactly one. Okay? So down here what we have is the classifications of systems of equations. Okay, consistent has at least one. Here I have one solution. Here I have infinite. You can't tell it, but there are two lines on top of each other, so every point on those lines are a solution. The parallel lines have no solution because they never intersect. And then on the consistent systems, if they are consistent, they either have to be independent or dependent. If they're independent, that means they have exactly one. If they're dependent, that's where they are the exact same and they have infinite solutions. So I would write this in my notes so that I could refer back to that as I'm doing my homework. It says determine if each system of equations is consistent and independent, consistent and dependent, or consistent and or inconsistent. So I need to solve this. So I'm going to add 7y to both sides. And those will cancel, so I get that x is equal to 7y plus 3, which I will then take and plug in for my x. So I have 2, instead of x I'm going to put 7y plus 3 minus 5y equals 15. So I distribute my 2, I get 14y plus 6 minus 5y equals 15. Combine like terms. This will give me 9y plus 6 equals 15. Now I'm going to subtract 6 from both sides. Cancels. So I have 9y equals 9. To get y by itself, I'm going to divide by 9 on both sides. And that gives me that y equals 1. Well, if y is equal to 1, I can plug that in here. So I have x equals 7 instead of y, I'll put 1 plus 3. 7 plus 3 gives me my x, which is 10. So my solution to this system is 10, 1. Because I have exactly one solution, that means that it is consistent and it is independent. Okay? One solution is consistent and independent. On the next one, we're going to do the same thing. They've already got an equation with y by itself for us. So we're going to take that and plug it in for y here. So I have 3x plus, instead of y, I'm going to put negative 3x, minus 4, equals 2. Okay. Distribute my positive. I have 3x minus 3x minus 4 equals 2. Combine like terms. Those will cancel out, so I get negative 4 is equal to 2. That is not true. And because it's not true, that means that these lines must be parallel to each other. So that means that it is inconsistent. Okay. If you wanted to double check that it was inconsistent, you could get this one in slope-intercept form to prove that those equations or that the slopes are the same. So if I subtract 3x from both sides, I'm left with y equals negative 3x plus 2. Again, I have that exact same slope, so it is an inconsistent system. Last example. Hannah and her mother are going on a bike ride. Hannah's mother leaves the house traveling at 13 miles per hour. Hannah leaves the house after her mother has biked 2 miles and tries to catch up by traveling at a speed of 17 miles per hour. Will Hannah catch up with her mother? If yes, when? So Hannah, okay, I'm going to put y sub h for Hannah's speed. And it says that, or Hannah's mother's speed is who we're talking about first, excuse me. Y sub m instead. So for the mother's speed, Hannah's mother leaves the house traveling at 13 miles per hour. So that 13 miles per hour is my rate, and rate is another word for slope, so I'm going to put 13x. And Hannah, it says, leaves the house after her mother has biked 2 miles. Okay, and she's trying to catch up with her by traveling at a speed of 17 miles per hour. So her mom has already biked 2 miles. So what I'm going to do is I'm going to add that 2 miles to her mom's equation because this is the speed she's traveling at, plus she's getting a 2-mile head start on Hannah. So then Hannah's speed is going to be 17x. We want to know if she will catch up and when. So I'm going to set these two equal to each other. 3x plus 2 equals 7x. Subtract 13x from both sides. Cancels. I have 2 equals 4x. To get x by itself, I'm going to divide by 4 on both sides. And that will give me that x is equal to 1/2 or 0.5. And on this means that it's going to take her half an hour to catch up to her mom, okay, because it was in miles per hour, so it's half an hour or 30 minutes for her to catch up with her mom, okay. If we wanted to check out how many miles that would be, then we could plug it in for our x. So if I put in 0.5 for x with a 13 here, or with x with a 17, I'll do it with 17. I could say that Hannah will have to travel, if I have half of 17, that would be 8.5 miles to catch up with her mom. That is all I have for you today. I hope that you've taken good notes, and I'll see you in class tomorrow. Have a good night.